All right. So tomorrow's the test, and I'll open it up at 6 a.m. and it'll close at 11:59. So make sure that you have the full 90 minutes available. Don't start it too late. As far as the test is concerned, just read every problem carefully. And you have to be very careful in when there are two populations, when you look at the difference in means or difference in proportions, make sure you understand what population 1 and population 2 is. And just don't rush into an answer. Because if you go into Minitab, when it looks at the difference in means and proportions, it always takes the population, the parameter for population 1 first, and then subtracts the parameter for population 2. But I may not set it up that way. I may have it the other way around. There's no reason to have it population 1 minus population 2. So just know that if the null and alternative hypothesis says population 2 minus population 1, and the alternative hypothesis says less than, then when you put it into Minitab, you have to switch it. Okay. So just
regarding that, I can ask a question. I feel like the p-value is normally it's less than 0.5. Is that correct?
No,
the p-value.
No, it could be anything.
Could be anything.
Any number between it's a probability, so it could be any number between 0 and 1.
Okay. Okay.
Doesn't have, because you've seen a few examples, and it's because they're all less than 0.5 doesn't mean that they have to be less than 0.5. They could be any number, 0 and 1.
Okay.
But I'm just warning you about that. This is really important. These are multiple choice questions, all right? And I'm warning you right now that when you compare the two means, read it carefully. Minitab is population 1 minus population 2 only. So if my null and alternative hypothesis says population 2 minus population 1, you need to switch the direction of the inequality. All right? Is that clear?
How can we tell if it's population 1 or 2?
Because it says so.
Okay.
It says it. It says it in the problem. If I give you a null and alternative hypothesis, it says it in the null and alternative.
Okay.
But if you read Minitab, if you go into Minitab, it's always population 1 minus population 2. So what I'm saying is, be careful with that, because I will provide the answer for the wrong answer. I'll give you the wrong answer if you well, and you'll get it wrong. It'll be a shame. You'll get it wrong, and part of being in statistics is being careful. People who do data analysis are careful people. All right, they don't make mistakes like that. But a lot of students do make those mistakes as they get nervous and they're, So I'm actually being nice here. I'm warning you about that. All right. All right.
Oh, thank you.
But it doesn't mean that you're going to listen to me. I'm just.
I plan to listen. I just am worried that I'll misinterpret what you say and go one extra level.
No, don't do that. Don't do that. I'm just saying read things carefully. That's all. Read it carefully. Make sure that you understand that Minitab is arranging it in a certain way, and because one of the options is for the alternative hypothesis is less than, greater than, or not equal to. Not equal to won't matter, right? It won't matter whether it's 1 minus 2 or 2 minus 1.
Right.
But the greater than or less than will, and you'll get the opposite. You'll get the wrong p-value. You'll get the complement of the p-value if you do it backwards. And I'm telling you, I'm putting both answers in the answer kitty. So this course is also about being careful with data. I'm not trying to be tricky, but you have to be careful. It's really important to be careful, because if you're going to be working in a data analysis role in any way, and you make mistakes like that, it could be devastating to the department. They may make the wrong decisions based on, right? If you get it wrong backwards. So I remember working in an investment firm, and I was in a data analysis role, and the guy who ran the firm, he doubled and triple checked work by giving the data to other people to double, triple check things, because he felt that it was very easy for people to make these types of mistakes. So, and in his case, it would be devastating to his business if he got things wrong. If data went out and it was just dead wrong, and then he had to apologize for it, you're losing. They'll lose faith in you. You know, your customers will lose faith in you. So it's not in the business world. I don't know about any other scientific world. I'm sure if you give the wrong dose of the COVID-19 to somebody, I guess that's not good either. But what I'm saying is you got to be careful with that analysis. That's all. That's all I'm saying. But I haven't finished the test yet. I'm actually finishing it up tonight, and then I have to take it myself to make corrections, because I make.
And make it easier.
Can I make it easier? All my tests are easy.
No, it's easy for
It's
you,
super
not
easy.
for us.
No, if anything is like, how should I say it? If it's not clear or anything, I change it. All right, I always do that, because if it's not clear to me, I'm certainly not going to be clear to you. You know, so that's why I take it myself. I also want to make sure that the time is adequate. I mean, 90. I mean, most of my tests typically are 70 minutes, but because of the request, I gave you 90 minutes. So you should not be having any issues with time, because I'm giving you an extra 20 minutes.
Well, from my point of view, I have work in the morning, so I know you're going to get it up at 6 a.m., but I won't be able to take it until,
That's okay.
5.
That's okay, because I know Rose works in the evenings.
Oh, right. Okay. Yeah, then she'll need it.
I'm doing it for her, and you guys could take it anytime. I mean, I would have it later in the day. No reason. That's why I have to finish it tonight, because it has to be available for her in the morning before she goes to work. Yeah. All right. So now let me get to the quiz, because I think all of you scored about the same. All right. It was about the same scores, which is telling me there's a basic idea that got missed.
I didn't get that.
I said all of you scored about the same on the last quiz, which is telling me that there was some basic concept that was missed. Maybe it's my fault. I don't know. But let's correct it tonight. All right. And Rose will hear this too on the recording. All right. So I'm going to just give me a second. I'm going to open up the quiz in Canvas. Oops, I can't do that. Please forget. So just it'll take a minute. And in the meantime, if you do have any questions, any other questions, I can answer them.
I do.
Yeah, I'm sure you do, huh? Go ahead.
I got so many questions.
Go ahead. Ask a question.
Like you mentioned the p-value before, I was a bit confused when I was doing the homework, because when I saw the question, there's a kind of question when someone proposed a better way to solve the problem and compared to the original way. Which one do you think is the population 1? Which one is the population 2?
Well, again, it'll be clear in the problem. It'll state it in the problem. It will.
It will be clearly stated like population 1 and population 2.
Well, it won't say population 1. It'll say which group is group 1 and which group is group 2. Yeah. It has to be stated, otherwise you wouldn't know.
Yeah, but in the homework, it didn't give us any like group 1 or group 2. It just says someone proposed a new method, and compared to the old method, the new method might be promoted.
Yeah, but the words in the problem said something like it improved, right? Maybe the mean goes up or goes down, whatever the improvement means. Well, that means that the improvement, improved thing, you can use as population 1 if you want, and the other one is population 2, and then do mu1 minus mu2 or whatever it might be. All right.
So the new one is gonna be population 1.
Well, yeah, because it's 1. That's the number 1 there. That means population 1. Yeah.
Okay, the old one is population 2.
Well, it's up to you. It's up to you. But if you switch it, if you make it mu2 minus mu1, all right, you have to make sure that you're stating which population is which, you know.
Okay.
But if it's an
I have a-
improvement, it's an improvement. It's basically, if the improved thing is population 1 and the old thing is population 2, then it would be mu1 minus mu2 is greater than 0. If it's, you know, maybe if the improvement means the mean goes up, then it would be greater than 0. And see what I'm saying?
Yes. Okay,
Yeah, I mean,
got you now.
it should be clear from the problem. The problem, the context, the words of the problem should make it clear which is which. But again, it doesn't matter whether you call it group 1 or group 2 or group A or group Z. It doesn't matter as long as you define what you mean.
Okay, I think I got you.
Yeah. Now, in a multiple choice test, it has to be clear, right? It has to be clear which one is group 1 and which one is group 2, right? It has to be clear. And that's why I'm saying that warning that I gave you earlier, because of that fact that it's going to be clear which one is which, and you have to make sure that you don't mess that up. All right.
Okay.
Yeah, but in a homework problem, you can define which group is what, and you can state the null and alternative hypothesis correctly based on the words in the problem. As long as you state everything and define everything, that it shouldn't be any problem. All right, let me get to homework. All right, let me share the screen with you here. All right, you can see it, right?
Mm-hmm.
Yes.
All right, so I think everybody did okay in the first question, right?
Yes.
The idea that the estimator of a population parameter is unbiased, and the expected value of the sample proportion is equal to the population proportion. The estimator is also called the point estimator as opposed to interval estimator. For an interval estimator, the blank level expresses the degree of certainty that the interval will include. That, well, that's the confidence level.
Right.
So that was, I think all of you did okay with that. Now this one here is where I think people ran into some trouble. Now, when you calculate a confidence interval using formulas, and specifically the margin of error, which is added and subtracted to what? The sample mean in this case here. All right, when you add and subtract the same number from the sample mean, that means that the width of this interval becomes 2 times the margin of error. Okay. And therefore, you just simply subtract these 2 numbers and divide by 2 to get the margin of error. Yeah.
Mm-hmm.
So the answer is 3. You know, 6.4 is the difference between the endpoints, and therefore half of that is 3.2. And then if the sample size is multiplied by 4, now you have to realize where in the margin of error formula is the sample size. Well, it's in the standard error formula. Margin of error is equal to the critical value, either a t or a z, times the standard error. Now, this is for a mean, so the standard error is going to be either sigma or s in the numerator, and the denominator will be the square root of n.
Mm-hmm.
So if n goes up by a factor of 4, that means the denominator, because it's a square root of that, goes up by a factor of 2. But the denominator goes up by a factor of 2, which means the whole fraction is 1/2 of what it was before. All right, does that make
Wait,
sense?
did you say what is the midpoint between 2.2 and 8.6?
3.2.
6.4.
No, it's 6. Yeah, it doesn't. Yeah, I didn't ask for the midpoint. I asked for the margin of error.
Oh, okay. Oh, I see. So it's
I didn't ask for the mean.
right,
sample.
right.
The
Yeah.
midpoint's a
Okay.
sample mean. I
I
didn't
think
ask
I
you
remember
that.
what I got wrong there. Okay.
Yeah, maybe you just missed. Yeah, see what I'm saying? That you know what you're doing, Steve. It's just you.
Yeah.
Yeah. So you have to be careful don't feel rushed. All right. Because 90 minutes should be plenty of time. Just make sure you read things carefully and you know exactly what you're answering. All right. Anyway, my point is that the sample size is in the denominator of the standard error. Standard error is the standard deviation divided by the square root of the sample size. So if the sample size increases by a factor of 4, the square root means that the denominator of the standard error increases by a factor of 2.
Right.
If you have a fraction where the denominator increases by a factor of 2 and you're keeping the numerator the same, that means the fraction decreases by a factor of a half, right? It's a half of what it should be. So the answer for answer 6 is just 1/2 of 3.2, which is 1.6. All right. And I believe somebody multiplied by 2 instead of divide by 2, but it's just because the sample size is in the denominator. So you have to be careful. You have to make sure you understand the formula. All right. That was what this question was all about. Now this one here talks about the power of the test. All right. First of all, the probability of rejecting the null hypothesis when the null hypothesis is true is, of course, the level of significance. And then the next one says the probability of not rejecting the null hypothesis when the null hypothesis is false is beta, right? It's called beta.
Mhm.
That's the answer to the next. Where am I missing? Yeah, it's a Greek letter beta. Actually, the first one is called alpha. The second one's called beta. Right? And then the last one says if alpha is 0.05 and beta is 0.35, the power of the test is equal to, well, the power of the test is the complement of beta, not alpha.
Right.
So it's 0.65 is the answer for this.
Okay.
Now the fourth question. Now, in the test, I should mention this for the test because of the issues I'm having with Canvas. It doesn't allow me to put a little hat above the proportion for sample proportion. So I am going to use as the population proportion, even though I don't like it. And P is the sample proportion, all right? Because it's unfortunately, that's all I can do. I can't figure out any other way of doing it in terms of putting it into Canvas. So it's unfortunate, but that's the way it is. So anyway, so let pi be the population proportion, let p be the sample proportion. Assume that the alternative hypothesis is pi is not equal to 0.7. The sample size is 100, then the standard error is equal to, well, the standard error for a proportion is the square root of the population proportion times 1 minus the population proportion divided by the sample size. It's the square root of that whole thing. All right, that's called the standard error. It's the square root of pi, in this case, times 1 minus pi divided by n. Now, if you don't have pi, like in the case of confidence interval, then you have to use the sample proportion, in that formula instead of pi. But you do have it here because it's a hypothesis test. So you ignore the sample proportion as far as the standard error is concerned. So the standard error is going to be the square root of all of that, 0.7 times 0.3 divided by 100, and that comes out to 0.0458. All right, I think most of you got that wrong. I think actually all of you got it wrong, I believe. All of you got it wrong. So it's a square. This is something you can calculate before you even do your statistics. All right, you run your sample. As long as you know your sample size, you can calculate the standard error. Now, why is that important? Because the standard error is the denominator of your test statistic. All right, in this case, it's a z test statistic. So the numerator is going to be your sample proportion minus the hypothesized proportion, which is 0.7. So it's 0.65 minus 0.7. And your denominator of that test statistic will be the standard error. So this is the denominator of your test statistic. All right. So to find the p-value in this case here, since the alternative hypothesis says not equal to, it's a two-tailed test. So once you have your test statistic, since the test statistic will be negative, right, because it's going to be, the numerator is going to be 0.65 minus 0.7, and then you divide by 0.0458, whatever that, I think that's just an approximation. Then you get your test statistic, and then the probability of getting that negative test statistic or smaller is going to be 1/2 the p-value, because remember, it's a two-tailed test. So then you have to multiply that probability by 2, and you should have gotten 0.275 as your p-value. And I believe one of you put half of that as the p-value, and you forgot about the idea it's a two-tailed test. Remember, with two-tailed tests, you have to take your probability, whether it's on the left tail or right tail, and multiply it by 2 to get the, right?
Yeah.
So this problem, for whatever reason, I don't think any of you did well on this. This was kind of not a good problem for you guys. But as you can see, it's in the formulas are in the book. So you just follow along. You just have to recognize the two-tailed test. That's why, I wrote it this way. So yes, two-tailed test. You have to remember that connection. Two-tailed test, multiply the probability by 2 to get your p-value. A one-tailed test, either greater than or less than, that is the p-value. All right. This question here, here you can see what I'm doing here. I'm specifying that it's mu1 minus mu2. Now I didn't have to do that. I could have switched this around. I could have said mu2 minus mu1 is less than 0, and it would mean the same exact thing. All right, Han, do you get that? Group 1 is yeah. So if I said this alternative hypothesis would be equivalent to saying mu2 minus mu1 is less than 0.
Right.
Yeah. All right. So just be careful with that. Just remember that Minitab, if you're using Minitab, always has group 1 first and group 2 second when they subtract the means and subtract the proportions. So if the problem is saying mu2 minus mu1 is greater than 0, you have to switch it. So that when you put it into Minitab, it's correct. All right, just be very careful with that. All right, then I'm giving you some numbers here, right? The sample sizes of groups 1 and group 2. Sample size of group 1 is 47. Sample size of group 2 is 53. I'm giving you the sample standard deviations. Group 1 is 10. Group 2 is 20. These are sample standard deviations, right? But it doesn't matter. I'm purposely saying the sample means that the two groups are unknown. Now, why did I say that? It's because I didn't want you to use Minitab. I wanted
What? That's so bad.
I wanted you to calculate this without Minitab. Yeah. So you couldn't use Minitab for this. So you actually had to go and look up, that page that has all those formulas in chapter 11, right? All those formulas that are in there. All right, anyway, the sample means, all right, if we assume equal variances, so that's the first column of that page where we have those formulas. We assume equal variances for the two groups, then the standard error used for the t-test is equal to blank. All of you got this wrong also. But it's not a hard problem, because now you should know that for a significance test, the test statistics, the denominator of the test statistic is the standard error. The denominator of the test statistic is the standard error. So you just had to go to the test statistic.
Oh, okay. Oh,
now,
so it was the pooled control.
You had to calculate the pooled variance first. That's the key. You have to do that first because that's in the
Yeah.
denominator of that's in the standard error denominator, right? That part of the test statistic in the denominator says SP squared.
Right.
Well, you have to calculate that first. You don't know what that is. It's not given in this problem, but you can calculate it from the data that's given here. All this data up here, the sample sizes and the sample standard deviations. You have to square these, by the way, right? To get the variance, sample variances, you have to square the sample standard deviations. So the sample variance for group 1 is 100. I made these easy so that you can do it in your head.
Right.
And the sample variance for group 2 is 400. It's 20 squared. Then you just plug it into that formula with the ends and everything, and you get your pooled variance. Once you have that, it's easy. Just plug it into that square root in the denominator of the test statistic with the 1 over n1 plus 1 over n2, and you get your answer. And the answer is 3.22. Now, if you reran this and assumed unequal variances for the two groups, then there's no pooling of the variances. It's simply the square root of the what I call it, the variance of each group divided by n, right? Variance of each group divided by n with the square root. That's the standard error.
Okay.
It's a denominator. The denominator of the test statistic is the standard error. Right?
I think the reason I got it wrong was because I was for some reason mistaking standard error for margin of error, and I kept thinking, oh, I need the t-value, but
there's no margin of error in a hypothesis test. It's in the confidence interval. The confidence interval, by the way, the standard error is multiplied by the critical value. It's the same standard error, by the way. It's exactly the same standard error. If we were going to create a confidence interval for this test statistic, right? If we were going to create a critical value for it, a confidence interval for it, we use the same standard error. It's exactly the same. It doesn't change. It's the same standard error. It's just used differently in the confidence interval because you're multiplying it by the critical value as opposed to dividing it into the test statistic for a hypothesis test. Does that sort of make sense now? Yeah.
Yeah.
And maybe I wasn't clear about that, and so there you go. That's why I felt like it was good to explain this all to you. I might have explained it, but maybe it just wasn't really clear. All right.
Yeah, I should have. Oh, okay. Yeah, I think I just miswrote something in my notes. Yeah, I was just. Yeah, I'm glad you did this review because I had taken a lot of notes for chapters 9 through 11, and so I was dismayed when I took the test and didn't do as well as I wanted.
Yeah. And for the column for the proportions, you can just use Minitab for that. You do a two population Minitab. It's for two sample proportion test in Mini. Just do it in Minitab. I'm not going to ask you for the standard error for that. It's complicated. That one is very complicated. If you look at the formula, it's not easy. So that one, I'm not going to ask you the standard error for that one. I'll just for a two population hypothesis test for a proportion. I will. You just use Minitab. The questions I ask will not require you to know the standard error for that. All right. Okay. Okay. I think that's it. That's all. I have to get back to the test.
Okay, I have to get back
to have it
question
ready for you. You have to
leave.
study, right? You have the project and all that. I don't know if you finished.
Yeah, I have to finish the project. I'm only in the middle section of it.
Yeah, and then you have to. Well, you can always again tomorrow before you take your test, as long as you have adequate time, you can study a little bit before you take the test.
I just got one more question before you go.
Yeah, go ahead.
And the level of significance, is it the same as confidence level?
No, confidence levels for a for a confidence interval. Confidence level is like 95% confidence interval.
Mhm.
It tells you out of all the possible sample means that you can have, and their corresponding confidence intervals, how many of them would actually contain the true population mean or proportion, whatever it is. That's called confidence level. Significance level is like 1%, 5%, 10%. It tells you what alpha is. It's the probability of a type 1 error.
Oh,
It's a probability. It's a completely different thing. It's the probability. It's a probability that you reject the null hypothesis when the null hypothesis is true.
okay. So
And we compare that, and that's what we compare to the p-value.
P-value. Okay.
Yeah.
So if we use the Minitab, we have something we need to change, the 95, 99 something. Do you remember
Yes,
that?
it's one of the options there. Yes.
That
If you
that
use
that
Minitab.
refers to the level of significance or the confidence level.
Say again.
That number refers to the confidence level or the level of significance.
I'm telling you, confidence level is only for confidence intervals. Significance level is only for hypothesis tests. The book actually tries to make connections between it. I find most students are confused by that. All right, that's an advanced concept that is most students. I say 99.99% of students. It confuses them when you start comparing the two. Don't compare them. I'm keeping them separate. Confidence level is for confidence interval. I explained what it meant a second ago. All right. And
so
significance level is the probability of a type 1 error, and that's it. That's it. Don't confuse the two. Don't confuse.
For the Minitab, the number, shall we change it?
Only if it's different than it. You talk about for hypothesis tests?
Yes. Yes.
All right. If it's asking for something other than 95%, which is it defaults to, yes, you need to change it. It's in the options. Make sure you go to those options, whatever those options that you have there, and change it. Yes, you need to change it.
And what's the keyword for that to change it?
What do you mean? What's the keyword? I don't know.
So
if I give you a significance level that's, well, first of all, confidence intervals you're not going to use Minitab for.
Okay.
I would recommend doing it the longer way, because it's just, I find most students mess up when they use technology for confidence. They do. They mess it up. So you might as well. I'm serious. I've tutored students, introductory students in statistics, and they are so confused about, you think the technology is helping them? It's making them more confused. So don't use the technology for confidence intervals. Just use the formula. Calculate your margin of error, and then add and subtract to the sample mean or proportion, and you get your answer. It's as really simple as that. Hypothesis tests, the only time I would recommend using the technology is for the difference between two populations, either difference between two means, difference between two proportions. Then it might make some sense to use technology. All right.
So as I understand, if you ask for a level of significance of let's say 0.1, 0.01, I will change that number to 99, and then I compare the p-value with 0.01.
I see what you're saying. If no. The level of significance, leave it as it is. Don't do anything to that. All right.
So 95.
Well, the level of significance is never going to be 95. It'll be a small decimal. Remember, we want the level of significance to be small, because it's an error when we reject the null hypothesis. We don't want 95% chance that we made a mistake. We want a 5% chance or a 3% chance. We want a small chance. So my point is, you can do that with Excel. All right, you can do that with Excel. I showed you how to do it with Excel to find the
Right.
p-value. Right.
Uh-huh.
I would just calculate the p-value using Excel.
Okay.
All right. Now, what I'm saying is for the difference between two means or the difference between two proportions, then you can use Minitab for those.
Okay.
I would practice that.
Okay. Thank
Practice.
you.
Yeah, don't take the test and then you're unfamiliar with what to do. You want to be familiar with what your strategy is going to be when you run into one of those, right? That's the whole point. And and the book has examples in there. Just do the examples that they have. They're showing you how to do it. Use Minitab and see if it matches the example answer. You're not going to break Minitab by trying. If you get it wrong the first time, you're not breaking it. Just try it again. Try something different and see if it works. And then you'll say, "Oh, now I know how it works."
Okay.
Me telling you, I'm explaining to you how I learn. I don't learn from somebody telling me. I learn by doing. All right. In statistics, you just do things and you learn that way, as opposed to hearing somebody say something. And I keep telling students, my introductory, not you guys, but other introductory students, and they just don't get it. You know, they want me to break everything down so they don't have to do anything. And then they memorize, and then if you switch words around, it's just like, but you didn't teach us that. It's like, yes, I did, but you're not learning anything. But I don't tell them that, of course. But all right, that's it. So did I answer your question, Han? I hope.
Yeah.
All right. Yeah, don't get those two things confused. Confidence level, significance level. Keep them separate in your mind, and then your life will be easier tomorrow. All right. And I will be my plan is to sit down, unless somebody interrupts me with other things, and sit down on Wednesday and grade everything that's left to be graded. There's only 3 of you, so I should be able to get everything graded, and by the, in 2-3 hours have your grades. That's my plan. Now, if it doesn't happen, you probably will realize somebody in my family said, "You got to do something other than what you're doing." So it might be, I might end up doing Thursday. I don't know. But
are you gonna include the regression part in your final?
yes, but it's simpler than the project. Simpler
As
than
we've done the project. Can you minimize that part?
All right, Con. You're trying hard.
Is that too much?
It's too much. I'll take it up. I'll take it under consideration, which may mean nothing
Thank
to
you.
you.
I appreciate that.
All right, guys. So I guess this is our final meeting together. So don't worry about tomorrow. Take it easy. Again, 90 minutes should be sufficient. And if you run into any issues where things don't sound right or are not working right, of course you contact me. I'll check periodically to make sure that you guys are okay. All right.
Okay.
So any issues with the internet or anything like that, don't worry about that, because I'll work with you with that. If your internet goes out in the middle of your test, and you run out of time, don't think that it's the end of the world. Okay. I'll work with you on that. All right. But if I don't get back to you right away, don't worry about that either, because I could be doing something and where I don't have access to your emails. So give me some time to respond also.
Sure.
All right. But don't freak out. You'll be fine. All right.
All right. Thanks, Professor.
You're welcome.
Thank you.
Yes. And
Have a good night.
and have a happy Christmas, New Year's, and everything else.
Yeah,
You
you
too.
too.
All right. All right. Take care.
Take care.
Bye-bye.
Bye. Bye.